Hello viewers, welcome back to my channel. In this session, I shall be discussing the priority scheduling algorithm which I had discussed already in the previous session, but this will be of preemptive type. So previous one we have seen the non-preemptive type of priority scheduling, and in this session we shall see preemptive type of priority scheduling. So already I have given the introduction to priority scheduling. Whenever we wanted to give more importance to a particular process, we need to give higher priority so that let that process complete its job. So that is sure, that is definitely there in the system. See, normally a process which is sending an email should be given lower priority than a process which is displaying a video on the screen in real time. Similar to that, not only these examples, we have so many other processes in the system which are competing for the CPU, and the system will decide to select a process of higher priority to get its job done first. So as I already discussed, a number will be assigned here to indicate the priority. In this example, we have taken higher number indicating higher priority. And moreover, one thing what I have done is I am using the same values for the arrival time and burst time, and once again carrying out with what? Preemptive mode. So it's considering what 7 processes P1 to P7, their priorities are given, their arrival time is given, and the burst time is given as 4, 2, 3, 5, 1, 4, 6. 4, 2, 3, 5, 1, 4, 6. So you people are now more confident in starting the problem. So start with the Gantt chart. So you need to show the running queue here. And now since it is preemptive mode of operation, what is the mode of operation? Preemptive. You have to be a bit careful, and always what you have to do is you start a process, schedule it only for 1 unit of time. Okay, stop, check whether other processes have arrived, and check the priority of the new process that has arrived. Whichever has got higher priority, whether the arrived process have got the higher priority than the one which is currently running, then you have to give what? You have to give CPU to the newly arrived process. So this is how you have to start now. Now let us begin. First we'll check here the process P1. P1 has come at a higher priority is for process P6, but P6 is arriving at time 5. So we don't have to schedule that now. At time 0, the only process that is available is P1. So P1 will start executing. But you need to stop P1 only, that means you need to schedule it only for 1 unit of time. But how much is the burst time for P1? 4. So because I have to keep track of the remaining burst time also, I'll start writing here because I need the complete column to indicate. So what you have to do is just check here. P1 you are scheduling it only for 1 unit of time. Immediately keep track that remaining burst time is for P1 is 3. So you have to keep track here. This is what is the remaining burst time. Then at time unit 1, check are there any processes that have arrived. Yes, at time unit 1 P2 has arrived. So you schedule P2, but you will schedule it only for 1 unit of time. How much? Only for 1, from 1 to 2, 1 unit of time. So, and just not to make errors, what you can do is at every unit of time, you can just keep which processes are available here by indicating. See, what you can do is at time unit 1, P1 was available and P2 was available. Fine. P1 is having a priority 2 and P2 is having a priority 4. So in our case, P2 will get scheduled because why? Because higher number indicates higher priority. P2 is having a priority 4. So you can keep track of the priority and the processes here, whereas keep track of the remaining burst time in this column itself. Okay, you have scheduled P2. At time 2, you just check are there any processes that have arrived? Yes. At time 2, P3 has arrived. Fine. So already you had P1, P2 and now P3 has arrived. P3 burst time is what? P3 burst time is 6. So P1 burst time is 2, P2 burst time is 4. Now which one will you schedule out of this? P3, because higher number. You will schedule it only for 1 unit of time. Stop at 3. Then check are there any processes that have arrived at 3? Yes, P4 has arrived now. Now, and moreover, you have to keep track of P3's remaining burst time also. P3 was having a burst time equal to 3. You have scheduled it only for 1 unit of time. So remaining burst time is there now. How much? 2 units is pending. Okay, next you have to schedule what now? At time 3, which are the processes that are available? At time unit 3, yes, here P4 has come, but already what? P1 was there, P2 was there, P3 was there, and now P4 has also come. Write down their priority, okay, so that you will not get confused. P4 priority is 10. Out of this, higher number is having with process P4, so P4 will get scheduled now. P4 at time unit 3, what is that you need to check? Which are the processes that have arrived? At time unit 3, P4 has arrived, so you have written here P4, write its priority time also. Out of this, P4 is having the highest priority, it will execute for 1 unit of time. Stop here and check are there any processes arrived, and also please don't forget you have to keep track for P4 the remaining burst time. So it is having how much? 4 units of time. Now after that, P4 will run for 1 unit of time, and at 4 you need to check 4, yes, P5 has arrived now. So already P1 was there, P2, P3, P4 and P5 has also come now. So P1 arrive, this one is priorities I am writing down here. P5 priority is 8. So look here, you have written at time unit 4, these are the processes available and with their priorities. Highest is P4. So P4 you have to schedule it. P4 you have scheduled it earlier. P4 will get scheduled it again, and P4 will run only for 1 unit of time. So where is that P4? Yes, keep track of its remaining burst time. Fine. Then at 5, at 4 to 5 you have yes, at 5 now check which are the processes available. At 5 you have P1, P2, P3, P4, P5 and P6 also has come now. Almost all, 6 processes are available at unit 5. Then what will you do? Which one will you select? Check their priorities. What is the priority for P6? P6 is having the highest priority, 12. So run P6 here for 1 unit of time, okay, at 6, and then check are there any processes arrived? Yes, P7 has arrived at 6. So finally your this one will be what? At time unit 6. I'll write here at time unit 6, P1, P2, P3, P4, P5, P6 and P7. Is it visible or shall I write it? At time unit 6, P1, P2, P3, P4, P5, P6 and P7. All these processes are available. And moreover, what you have to do is now at time unit 6, when you see out of all these processes, write their priorities also. P7 priority is 9. Okay. P7 priority is 9. So which one will you schedule? Then definitely the highest is what? P4 here. P4 will get its chance here. P4 will run for how much unit of time now? Will you do it for 1 unit of time or will you carry out here for the remaining burst time? See, look here, your job is to check up till where? Up till the maximum value that is mentioned here in the arrival column. Arrival time column is which one? Here. Maximum value is 6. So keep track all the processes, their priorities and their burst time properly up till here. After that, it becomes non-preemptive. Then at this particular time 6, you have all the processes. It is easy for you now to check, to select one from this which is having the highest priority. So among all these processes at time 6, process P6 is having the highest priority. Okay. So earlier, what is that? Have I missed the keeping track of P6? P6 has completed from 5 to 6. So P6 earlier burst time, yes, pending burst time was 3. From 5 to 6 it has completed, no, that 1 unit I am subtracting here. Then come what? At 6, once again P6 will start, but this time P6 will not be preempted because there are no other processes that are going to arrive in future. P6 will complete its job, so it will end at 9 because its remaining burst time is 3 units. So this one will go out now from the list. Then comes P4. P4 is here, its remaining burst time is 3, completely it will get scheduled 9, 10, 11, 12, yes. Now it becomes a 0 here, fine. So P4 will also get removed from this. After that, you have to see how many, yes, there are 1, 2, 3, 4, 5 more processes. Now P7 will get as per this because its priority is 9. P7 priority is 9. So P7 will get, it is having the burst time 6. It will completely use that 6 units here. So it will end its job at 18. Then comes, okay. So you have completed even P7. Then comes P5. P5 is here. P5 is remaining burst time. P5 is having only 1 unit of burst time. So it will end its job at 19. Then comes P5 is also over. Next only 3 processes are there. The turn is of P3 now. P3's burst time is 2. Okay. 21. It will end its job at 21. Then comes P2. P2 priorities this one, and P2's remaining burst time is only 1. Okay, here 1 minute. P3, where did we execute P3? Yes, P3's burst time is 2, 19, 20, 20. So it became 0. No, that I have to mention. Okay. Yes. So P3 has completed its 2 units of burst time. It became 0. Then after that is what P2? P2 will have how much burst time remaining is only 1 unit. So it will end its job at 22. Fine. P2 is also over. The last one is what? P1, which is having 3 units pending now. That also will schedule now for P1. Okay. And it will end at 25. So this is how you have to fill the values in the Gantt chart. Once you do this, completion time, you have to check here. P1 is here, once again appearing at the end. So P1 completion time 25. Let me fill fast now. P2 completion time, P2 is appearing first here, but it is ending its job here at 22. P3 at 21. Then P4 at 12. P5 at 19. P6 at 9. P7 is ending at 18. So these are the completion time. Now same way how you have carried out the completion time minus arrival time will give you the turnaround time. 25 minus 0, 25, 21, 21 minus 2, 19, 12 minus 3, 9, 19 minus 4, 15, 9 minus 5, 4, 8, 12. Now you have to calculate the waiting time. So waiting time is equal to turnaround time minus of burst time. 25 minus 4, 21. 21 minus 2, 19. 19 minus 3, 16. 9 minus 5, 4. 15 minus 1, 14. 4 minus 4, 0. 12 minus 6, 6. So these values you got. Finally, you have to compute the last column values, that is the response time. So already I have told you what is that you will do. Response time equal to CPU first time. That means for the first time when CPU was allotted to the process minus of its arrival time. This is the formula. So that way if you see for the first time when CPU got allocated to a process, you can check from the Gantt chart. So look here, for the process P1, CPU was allocated immediately at time 0, but its arrival time is what? 0 only. So the response time will be 0, this 0 minus 0, response time will be 0. For P2 it got here, arrival time is 1, so 1 minus 1, 0. P3 was allocated, okay, at time unit 2, arrival time is 2, 0. P4 allocated at 3, arrival time is 3, okay. Then P5 got allocated here for the first time, yeah. So P5 is allocated at 18, but it has arrived at 4. So its response time will be 18 minus 4, 14. P6 here. P6 got allocated here for the first time. Its arrival time is 5, 5 minus 5, 0. P7 got allocated at 12. Its arrival time is 6, 12 minus 1, 12 minus 6, 6. The values are in such a manner, if you see at the response time, every process is getting a chance to start its task here. Response time, if you see, allocated almost immediately, okay, after their arrival, except for two processes here. Now, as you have done for the previous one, calculate the turnaround time, waiting time and response time. So, turnaround time is 105 and this is how much? 20. Okay. So, what is that you have to do? Always you have carried out no average turnaround time 105 divided by 7 because there are 7 processes. Average waiting time 80 divided by 7. Then average response time 20 divided by 7. What compare the response time of this particular numerical with the response time of the previous one, which was non-preemptive in nature. The value what you got for the response time in the previous problem was 9.57. Here you got 2.85, which is comparatively what? Very good. So it means what? The conclusion is the processes are getting what? Very quickly the CPU allocated to start their job. This is how you have to carry out the numerical for a priority scheduling, and this one is what? Preemptive in nature. So preemptive mode of operation, carry out in this manner: start a process, schedule it only for 1 unit of time until you reach the maximum value that is mentioned here in the arrival time column. After that it becomes what? Non-preemptive in nature. It becomes easy and simpler also for you to fill the values. So request my viewers to like, share and subscribe to my channel. Hope this session is useful to you all. Thank you. Bye bye. Take care.